you to go with Unit 4, Lesson 1, Variables, Explore. In Unit 4, we're going to learn about variables and then conditionals and functions. You're going to get into a lot more of the programming aspect, which is fantastic. You're going to do a lot of things on your own with help from me and from your peers. Every one of these topics, variables, conditionals, and functions, will be broken into 4 lessons. The first for each will be an exploration. That's where I'll do a lot of the guiding. Then the investigation. That's where I'll lead you along with some investigation. Then you're going to practice, because you got to practice doing stuff. And then finally, you're going to make, meaning you're going to make some code. You're going to write some code that uses whatever topic it is we've been investigating. So without further ado, let's get started with Unit 4, Lesson 1, Variables, Explore. At the conclusion of this lesson, you will be able to use appropriate vocabulary to describe variables, expressions, and variable assignment. You'll be able to evaluate expressions that include numbers, strings, and arithmetic operators. And you'll also be able to trace through some very simple programs that use variables, expressions, and variable assignments to figure out what happens throughout the program. Now, in the warm-up for this Unit 4, Lesson 1, go to Unit 4, Lesson 1, Level 2 on Code Studio. There are a few things here that you will be able to do, and sometimes when I'm going to tell you to pause the video and jot some things down in your notes and then check yourself. There are other things that, well, quite frankly, we just can't do because we're not all together if you're just watching the video on your own. Now, if you take a look at Unit 4, Lesson 1, there are 3 different apps there. These are samples of the kinds of apps you're going to be able to build by the end of this unit. As you go through them, what I'd like for you to do is take about 3 minutes, pause the video, go through these, and write down at least 2 examples where the app seems to be keeping track of a piece of information or using it to make a decision. We're going to come back to this in future lessons. But again, figure out what's going on. What kind of information is being maintained and what's going on with it? Is it being used to make a decision? Is it being used to track something? Okay, so again, you have one that looks like this. You have my favorite one, the pet rock. Pause the video for about 3 minutes and just do a quick look at these. Okay, you're back. Well, in the last unit, we built apps that mostly focus simply on input and output. For example, when a button clicked, it showed a picture. When a button was clicked, it changed a screen. When a button was clicked, it played a sound. There wasn't really any processing, okay? It was just switching things around. There weren't any decisions being made. There was no data being tracked. But we don't want our programs to do more than that. In this unit, we're going to learn how to build apps that keep track of information and use that information to make decisions and to perform calculations. This is going to let us build much more powerful and much more interesting apps. So let's get started by diving in deep on what's involved with programming with information. Now, I will say that parts of the unplugged portion of this lesson cannot be done easily with social distancing or if you're absent and watching this video because you were absent all by yourself. For that reason, there are sections where I will walk you through what we would do in class if we were in person and in groups, and I'll have you do things that you can do on your own. We're then going to move on in the future lessons to activities and explorations that you can certainly do while either socially distanced or at home on your own because you were absent due to illness or other excused reasons. Now, today we're going to explore the topic of variables. You and your partner, if we were in class, I would give you a small stack of red and yellow stickies and 3 plastic baggies. I would also give you, I would not necessarily give you, you would get a pen or pencil. You should have that, and a dry erase marker. Those I would come up with. Now, we're going to be thinking about how computers work with information. We're going to call one piece of information a value. Right now, there are 2 different types of values, numbers and strings. There are a few ways to tell them apart. Numbers work the way you would normally think of numbers. They are made of the digits 0 through 9. We are going to put numbers on yellow sticky notes. When we write numbers, you don't need quotes. Strings are made of any characters you can see on the keyboard, which means all these examples count as strings. Strings go inside double quotes. You can see how it would be important to tell the number 123 apart from the string 1, 2, 3. Now, if we were all together, I would tell you to do this. Make one number and one string. Share it at your table. So numbers would be digits, 0 through 9, and you can make any number you want and put it on a yellow sticky. Strings, you need to use double quotes and put them on your pink or red, well, probably be pink stickies. They don't really make bright red ones. Now, operators. This is great, so we can store things. Well, an operator is just a fancy name for the plus, minus, multiply, and divide symbols. An expression is a combination of two sticky notes and an operator. When I ask you what's 2 plus 3, you immediately say 5. You just evaluated the expression 2 plus 3. Or figure out what the value is. Since 5 is a number, we put it on a yellow sticky. When evaluating an expression, we follow order of operations, just like in math class. So again, if we have 2 plus 3, that evaluates to 5. Now, what if I gave you 5 minus 1? What would that evaluate to? Hope everybody said 4, and that you would put it on a yellow sticky. Combination of operators and values evaluates to a single value. You would evaluate everything and you would get a single value. Now, this table shows the different ways we can create expressions. We can use all 4 operators with numbers the normal way. We can add any 2 numbers, subtract one number from another, multiply, and divide numbers. Okay? You can only use the plus operator, and it connects the 2 words. When you're using strings, you can only use the plus, and it connects the 2 words together. We also call that concatenation. Concatenation. If you're connecting a number and a string, the number first gets converted to a string, and then it is concatenated. Concatenated means simply put together. So if we take a look over here, we have 3. We've got 3 plus 4, which evaluates to 7. 5 minus 2 would evaluate to 3. 11 times 22 evaluates to 22. Did I say 11 times 2? Okay, sorry. 10 divided by 2 evaluates to 5. The string 4 with the string ever concatenated to the back of it becomes forever. If you put the ever first, you would get ever 4. Okay, so it just squashes them together in the order that they're in. GR plus the number 8 first changes this number to a string and then concatenates it to get great. 2 plus day first changes the number 2 to a string 2 and then concatenates that with the string day to evaluate to today. If you're using 1 or 2 strings, you can only use the plus operator. The others simply don't make sense with strings. Now, pause the video for just a moment and try evaluating these and see what you get. Once you've put your answers down on paper or thought about them in your head, go ahead and start the video again and see if you got the right answer. All right, 4 plus 5. Did you get 9? 10 minus 9. Did you get 1? And notice 9 and 1 should be on yellow stickies because those are numbers. Tree concatenated with house should be tree house. U plus R should be your. I concatenated the U and the R. 3 plus D first made 3 into a string and then concatenated them together to get 3D. Now, we're going to call the plastic baggies on your table, which you don't have if you're watching the video. but in person you would have plastic baggies on your table. We're going to call plastic baggies variables. Variables can hold at most one value, or sticky note. Variables have names, just no quotes. They include no spaces, and they must start with a letter. For now, practice making a variable with your partner. And again, a variable is just the name of the container that will hold the value. Variables are like our plastic baggies. They can hold at most one value or sticky note. The name uses no quotes, includes no spaces, and must start with a letter. Here I have zip, and I have whoop, and I have zip too. These are 3 different bags, so it's 3 different variables. I have 3 different places where I could store something. Now, make one variable with any name you like and share it with another group. And again, can't do that online, but that's what we would do in class. Next up, we're going to look at variables and expressions. We can evaluate expressions that include variable names. To do that, first make a copy of the sticky note inside the variable. Then evaluate the expressions the way you normally would. These 2 examples show you how. So if I have zip and I store the value 5 in the container called zip, and I have bop, and in bop I put hi. I have 3 plus 5. Okay, or if I have 3, if I do 3 plus zip, okay, that's 5. It evaluates to 8. This is if, if instead of having 5 here I had zip, I would put the 5 in. And it evaluates to 8. Now, the bop plus zip, well, that's where I have bop. What's in bop? Hi. What's in zip? The character or the digit number 5, the value 5, because I'm going to add that to a string I'm concatenating. So notice how the yellow turns into a pink, becomes a string, so that I evaluate to high 5. All right, now I want you to try to do this. Even though we don't have baggies, they're drawn here. Evaluate these expressions. Make sure you pay attention to whether it evaluates to a string or a number. If it's a string, use double quotes. 3 times boo. R-A-R, rar, plus ep, and rar plus boo. For this first one, did you get 12? It's just a number. 3 is a number. Boo contains a number. Rar plus ep. This is the string. Rar contains a string be. Concatenated with ep becomes beep. Rar plus boo. Rar is b. Boo is 4. I'm going to change the 4 to a string, so now I'll get the string b4. Let's start writing some programs that control our variables. We're going to stop using stickies, but we'll highlight strings and numbers to help you remember the difference. Var creates a new variable. So when we say var, we're telling the computer, create a new spot in memory to store something. Basically, that means grab a new baggie. Write the variable's name on the baggie. So here's what a program looks like. The var command tells the computer to create a variable. Var pow. Grab that baggie and write pow on it. The assignment operator. Assign is a fancy name for putting a value inside the baggie. So if we have a program that says var pow, pow gets assigned 3, pow gets assigned 5. Okay, remember that variables can only hold one sticky at a time. So if there's already a sticky note in there, we have to throw it away. So pow gets 3 and pow gets 5 means that right over here, the 3 gets thrown away so that now pow has 5 in it. So var pow grabs a baggie, names it pow. Pow assigned 3 puts 3 into the baggie. Pow assigns 5, tosses the 3, and assigns the 5. But wait, in a computer, you don't actually put the old number in a trash can. It's just deleted, totally deleted. The numbers are stored as electrical charges somewhere in your computer's memory. When you assign a new number to a variable, it actually erases the old number and stores the new number in its place. So pause the video and do this and figure out, what do we have over here? What are the names of our variables and what's in the variable? Great, you're back. Well, var pizza creates pizza. And then pizza 3 puts the value 3 into pizza. Var tacos creates our variable tacos. Pizza gets yum put in. And then tacos gets the best put in. Okay, now notice this one, I just pulled this off because this essentially gets thrown into a trash can. Okay? Now, assign a variable with an expression. Ooh, getting fancy. We're going to evaluate the expression first to get one value, and then we're going to assign the value as normal. Now, the funny thing here is we work on the right-hand side of the assignment operator. Once we have a single value, then it's stored into the variable that's on the left-hand side. So let's combine what we've learned. You can use the assignment with expressions. In order for this to work, you need to evaluate first, then assign. This makes sense because we know we can only put one sticky note in the variable baggie. So var pow creates our baggie named pow. Pow is assigned 1 plus 2, says that I have to first do 1 plus 2, evaluates to 3. I then put that value into pow. Then pow gets assigned 3 plus 4. Well, 3 plus 4 is 7. So what happens? The 3 is totally deleted or trashed, and pow now holds 7. Wow. Well, here's a crazy one. Run this program. Compare your result with another group. Var, zow, var, fly. Created zow and fly. Fly gets today. And then zow got 4 minus 1. Fly got 3 times 3. Zow got 4 plus now. How did that work? Let's see. There are a couple of ways. You can do the baggies, but I want to show you a way that you can also go through a program if you need to. And we have zow and we have fly. These are our two variables. Fly gets 2 concatenated with day. So I'm going to have today is now inside of fly. The next line comes down and says 4 minus 1 gets put into zow. So there's a 3. Fly gets 3 times 3, so it's replaced with 9. Zow gets 4 concatenated with now, so it gets 4 now. Notice that's what winds up at the end. So if you want to trace through something, every line is what happens to the next one. So zow had nothing at first, just fly. Fly continues to have today, even after this, this doesn't change fly. This changed fly. Okay. So you just can trace it through that way. That's another way of tracing it through. You don't have to have baggies and stickies. Now, we're not going to highlight our strings and numbers anymore. We can just use double quotes and the strings around the strings to tell the difference between strings and numbers. So, if we assign a variable expression, if we assign a variable, expressions with variables, here's our big example, and this is what we're going to do. Okay, so let's see how this works. Var kit. Var kit says create a baggie, grab a baggie, and write the word kit on it. Kit is assigned the value of 1. That says take the value 1 and put it into kit. Var boo. That says grab another baggie and write the word boo on it. That container's name is boo. It doesn't change anything with kit. Kit is still sitting there with the value 1 inside. Next line says boo gets assigned the value of kit plus 1. Well, I have to run over here. Kit has the value of 1, plus 1 is 2, so boo. I'm going to store the value 2 into boo. The next line says kit gets a value of 5. Well, that means I'm going to take the 1, throw it away, delete it, and I'm going to replace it with 5. Remember that variables aren't connected. Changing kit doesn't change boo. Up here, boo is equal to kit, or is set to the value of kit plus 1. This is set to whatever kit is now. Once I evaluate kit plus 1 and store it in boo, if I come down and afterwards I change kit, it doesn't change boo again. They're not connected. Okay? Boo has his 2 in his little baggie and runs off, does his thing. Now, try this. You can't run this program, but we're going to look at walking through this and tracing it. And because we're going to do it together, you can't really compare your result with another group. Because again, we don't have groups and we don't have baggies. So, variable fuzz. Here's my baggie called fuzz. Variable clip. I'm going to create another container called clip. Into fuzz, I'm going to put the value 5. Into clip, I'm going to put the value 2. Or fuzz, sorry, not 2, but fuzz plus 2. Fuzz is 5 plus 2 is 7. Then fuzz is going to get clip plus 1. Well, clip has 7. 7 plus 1 is 8. Clip is now going to get the string gr plus fuzz. So fuzz, I'm going to have to change 8 into a string. So now it's the string 8. I'm going to concatenate that with the gr. So now clip will have gr8 or great. Then I'm going to come back up here to fuzz, and fuzz is going to have whatever's in fuzz plus 1 more. Well, that's 9. Now fuzz is going to have fuzz plus 1 more, which is 10. And then fuzz, I'm going to assign it fuzz plus 1. What's in fuzz now? 10. What's 1 more? 11. 11 is what will be stored in fuzz. So that is stepping through and figuring out what should be in the variable at the end of the program run. Key takeaways from this. Numbers and strings are 2 different types of values. Expressions evaluate to a single new value. So 10 divided by 2 evaluates to 5. 2 different values, 22 is a number, high is a string. Strings must have quotes. When variables are in the expression, just make a copy. Don't change the actual variable. Variables are assigned a new value. Pow gets 1 plus 2. 1 plus 2 evaluates to 3, so 3 gets stored in the container or storage location named pow. You evaluate first and then you assign. So pow, I don't know if I have to do what's over here on the right and then assign it to the left. Old values are deleted forever. As soon as I put 3 plus 4 into pow, I have no way of recovering what was previously in pow. It's gone. So old values are deleted forever. Assignment just moves information around. It does not connect variables. In some languages, including JavaScript, which is what you all will be using to create your apps, the assignment operator is not written as an arrow. Instead, it is written as an equal sign. But within JavaScript, it means is assigned to the value, not the word equals. The command fuzz is assigned the value of fuzz plus 1. In JavaScript, is written as fuzz is assigned the value, use the equal sign, fuzz plus 1. In math, equals means are equal forever. Well, in math, this could not possibly be true. If I have fuzz plus 1, it can't possibly, there's no value for which fuzz plus 1 can equal fuzz. But I can add 1 to fuzz and replace the old value. Now, in programming, equals means put this value in this variable. Okay. We'll see more of this next time. In our wrap-up, you all need to know what the word expression means. An expression is a combination of operators and values that evaluates to a single value. As an example, pow is assigned the value 1 plus 2. That means that the value 3 now is placed into the variable pow. A variable holds one value at a time. It's the name of a storage location. Assignment operator. This allows a program to change the value represented by a variable. You either use the arrow that points to the left or equals. Because we will be doing JavaScript, we'll see the equal symbol. But again, in JavaScript, it means is assigned a value. In the next lesson, you will investigate the use and properties of variables. Till then, have a great afternoon, evening, day, weekend, whatever's coming up next.